Okay, so let's continue the topic 3. So as you can see here, now we are moved to the second part is about intermolecular interaction. So as I have mentioned, so intermolecular interaction is weaker than the intramolecular interaction. However, this one is very important when you consider the physical properties. For example, the physical state, a liquid, solid, or the gas form of the chemical, or when you can compare the when you would like to compare the boiling point and the melting point of the chemical together. So the intermolecular interaction can be divided into 6 subtypes. The first one is hydrogen bonds. This one is very special bonding. And the next two interaction is related to the ions. It's we call it ion dipole or ion-induced dipole interaction. And the last three interaction is belong to the van der Waals interaction. It's also is well known which type of interaction is related to the dipole interaction. And now we can consider each particular interactions. Hello, can you file the lecture note on? Can you find the lecture note on Google Drivers?
I have found it.
Okay, nice. So it means when I keep the lecture note on the Google Driver, it means that you don't need to take note or something is mentioned here. However, at some point important, so you should write down in your notebook. Okay. Okay. So then now it's time to go in detail for each type of intermolecular interaction. The first one is the hydrogen bonding or hydrogen bond. So the hydrogen, what is the hydrogen bond? This one is very important. One of the very important bond. For example, you know that the hydrogen bond you can find somewhere. For example, in water, there is a hydrogen bond between the water molecules, or even in our body, in DNA. DNA, there is also a hydrogen bond, and hydrogen bond plays a very important role in the DNA. You know that the combination between the particular nucleic acid is also because of the hydrogen bond. And so what is the hydrogen bond here? First one, maybe we spend time a little bit for the definition here. So the hydrogen bond is partially electrostatic interaction. The first one is electrostatic interaction. Okay, however, it's not electrostatic interaction. It's only partially. It means that they have a characteristic. However, it's not 100% of electrostatic interactions. Okay, and this one is between a hydrogen bond to more electronegative atoms. You can see this one is a very long definition, however, so you must divide the definition in a different part and we can interpret each part. The first one is electrostatic attractions, okay? The second point, the second part is, maybe I will use a different colors, between atoms, hydrogen. However, it's not only the hydrogen, it's the hydrogen atoms bond to a more electronegative atoms or group, sorry. The second one is because the hydrogen atoms, so they should have the hydrogen. However, this is not the normal hydrogen atoms. The hydrogen atom bond to more electronegative atoms or group, okay? And the attraction between the hydrogen atoms and another atoms, which bearing a lone pair of electrons. You can see this one is divided into 3 parts. Yeah, it's not so nice when I draw by my hand. However, this one is. You can see that there's 3 parts here. The first one is electrostatic between hydrogen atom and another atoms. How the condition is hydrogen bond to more electronegative atoms, and another atom also bearing a lone pair of electrons. So in this case, the first one here you can see the hydrogen atom bond with the blue color here. This one is for the blue colors. So the hydrogen bond with the electronegative atoms. So which type electronegative atoms we consider here? The first one is fluorine. Okay. The second one is oxygen. Next one is nitrogen. So at this point, we consider only three type of elements. Oops, sorry. The three type of elements. Okay, with fluorine, oxygen, and nitrogen. So when hydrogen bond with such element, so the hydrogen is can consider to involve in the hydrogen bond. So hydrogen bond with fluorine, oxygen, and nitrogen. Okay, so in this case, you can see that in hydrogen atom there is one partial positive charge. Okay, and on the electronegative atom here is also contain a partial negative charge. And so between the positive charge and the negative charge is electrostatic attraction. Okay. For example, when you consider the water molecule, you can see here. So here's I draw the picture of two water molecules. Okay, there are two water molecules. There are two water molecules, and so please be careful here. So each of OH bond here is OH bond here is inside the water molecule. So this one is intramolecular interaction. It's not a hydrogen bond. Some of you also, okay, after this, the topic 3, I asked, okay, what is the name for this OH bond? Okay, this one is hydrogen bond. Oh my goodness, this one is not hydrogen bond. This OH and this OH is covalent bond because it's the same molecules. And the similar in the same way for this OH and this OH group, this one is covalent bond. And the hydrogen bond is the intermolecular, or this is the interaction between the two or more molecules. For example, here you can see the first water and the second waters. So here there is wait a bit.
Còn khóc. Tao mệt. Chị này. Ok nha.
Okay, so let's continue here. So here's when we consider the two water molecules. So now, as we can see here, okay, so the electrostatic attraction between hydrogen atoms. So here, this one is hydrogen atoms one, okay? This hydrogen is the red hydrogen atom here is bound to oxygen. And because oxygen is a electronegative atom, so here's a hydrogen has a partial positive charge. Okay, so this one is hydrogen atom when we mentioned in the definition here. Hydrogen atom bond to more electronegative atom or group. Here they bond to oxygen. And the attraction between hydrogen atom and another atoms. So another atom here is oxygen. How oxygen is from another molecules. Another molecules. So it's a attraction between hydrogen of this molecule and another oxygen of the next molecules. And this one is a hydrogen bond. Okay, this one is a hydrogen bond between the and in the similar way you can see that this is hydrogen atoms. And similar way you can see that so these hydrogen atoms can produce hydrogen bond with another oxygen atoms from another water molecule, and a similar way with this hydrogen atom and this hydrogen atoms. So it means that in the water there is so many hydrogen atom bonds. Yes, is I so the structure of only like this one is a hydrogen bond between only two molecules. And let's image when you have a thousand or billions water molecules, it will produce a hydrogen bond network. Okay, hydrogen bond network. And now as we come to the questions, okay, let's consider the aqueous solution of hydrogen fluoride. So let's consider the water, the aqueous solution of the hydrogen fluoride. The hydrogen fluoride. Now I mentioned here, okay, the aqueous solutions. Aqueous solution, HF, okay, hydrogen fluoride. So let's think about the hydrogen bond in such solutions. So how many type of hydrogen bond in the aqueous solution of HF? Let's think a little bit about these questions. So how many type of hydrogen bond in the aqueous solution of hydrogen fluoride? We can think about a few minutes and then we can discuss this one together.
Bạn cũng chắc có tổ chức gì.
Okay, so now let's come back to the discussion questions. Do you have any ideas about this kind of questions? So aqueous solution of hydrogen fluoride. So how many type of hydrogen bonding? Văn Đức, Mr. Văn Đức, Hoàng Văn Đức.
Always add with
Lê Phúc Thịnh.
Yeah.
Okay, so let's discuss this question. How many type of hydrogen bonds in aqueous solution of HF?
One hydrogen bond.
One type hydrogen bond between which molecular and which moleculars?
Yes.
Between which molecular and which moleculars, please?
oxygen.
HF and SO2. H2O.
So it means that between HF and waters. And now, so what happened with the HF and HF, water and waters?
FF and FF is
Is there any bond, hydrogen bond between HF and HF?
no.
No. Why is there no between HF and HF?
It's polar covalent bond.
Okay, so thank you. So let's take a look on the screen. So based on the definition of the hydrogen bond, you can see that HF. So HF is hydrogen. So HF is bond between hydrogen and fluoride. Fluoride is electronegative, the most electronegative atoms. So HF and waters, let's consider each structure of each molecule. So you can see why I mentioned the structure of the molecule at the beginning. We need this kind of information to go further. Because oxygen and fluorine, both of them are electronegative elements, I have mentioned. So now, in this case, in HF, should has partial negative charge on fluorine. The same with oxygen, okay? And for hydrogen here, in both of molecular, hydrogen has a partial positive charge. Now let's see what happens when we consider the mixtures of these two atoms, two molecules. How many types of hydrogen bonding can form in the aqueous solution of HF? Đức Anh, Đàm Đức Anh.
Two types of hydrogen bonding.
2 times. Which one? Between which one and which one?
Hydrogen,
Sorry, I cannot
chloride
hear you
and
properly.
không phải là liên kết giữa hydro ở HF với lại oxy ở nước và hydro ở nước với lại lo ở HF ạ.
Okay, so the first one is between hydrogen of HF and oxygen of waters. Okay, it's first one is the right questions. Hydrogen and oxygen of HF and hydrogen and oxygen of waters. Okay, so let's think about, okay, the first one is the first type of hydrogen atoms, the hydrogen bond. Okay, so between hydrogen of fluoride and oxygen of waters, and now another one is between hydrogen of waters and fluoride of HF. Similar with this one, however, it look different. It's between the hydrogen of water and fluoride of HF. So is there another type of hydrogen bond? Ngọc Minh, Phạm Ngọc Minh.
Can you repeat the question because the connection is not.
I don't know. It has problem with the internet connections. Okay, so only when I ask the question, there is a problem with the internet connections.
No, tại vì em thấy nó
Okay, so is there another type of hydrogen bond in the AHF solutions? Is there another different type of hydrogen bond? So your friend has already mentioned 2 type hydrogen bond. First one between hydrogen of HF and waters, oxygen of waters. And the second one is between hydrogen of water and fluorine of HF. And now is there another kind of hydrogen bond here between in the solution here, in the aqueous solution of HF?
I don't think there's another one.
Another one?
No, I don't think. I don't think it's another one.
Okay, so now let's consider the hydrogen HF and HF. Is there any hydrogen bond between HF and HF? No, yes.
No.
Why no? Let's consider 2 HF now. Why you say no? Why do you say no?
Oh yeah.
Why do you say there is no hydrogen bond between HF and HF?
I think I'm wrong.
Okay, so you can see positive charge on hydrogen and negative charge in fluoride. So fluorine. So this one, okay, another type of hydrogen bond. So is all of the hydrogen bond or another type?
I think it's enough.
No, it's not. Now let's consider water and water. What happened with the water and water molecule here? Is there any hydrogen bond here?
Yes, with the. hydrogen and oxygen.
Let's see that. Okay, so now in the HF solution, not only HF or waters, however, if both type this one, so they have 4 type hydrogen bond. Please consider the definitions. Okay, so 4 type hydrogen bond between the hydrogen bond with electronegative element and another electronegative element. Not only between H and with the same type molecule or different type molecule here. You can see in the list here, there are 4 type hydrogen bond. Okay, this one. So please spend time, please use your brains to think about the questions. Okay, now we can continue the lectures. With this kind of example, I hope that you understand what does it mean hydrogen bond. Okay, so next one, as you can see in the list here, so only one special one is hydrogen bond, and the hydrogen bond can be considered one of the strongest intermolecular interactions. And for the remaining interaction, you can see that you can observe the dipole. You can observe here the concept of dipole. But what does it mean, the dipole? And now we can come in detail about the dipole. And please remember here, because you can see that there are 5 types of interaction related to the dipole. So it means that if you don't understand what does it mean the dipole, you cannot understand the interaction. That's why I must spend time to talk about the molecular dipole. What does it mean the dipole? This is about dipole. Okay, so let's talk about electric dipole. Electric dipole. Okay, the electric dipole. So in the physics, so electric dipole is the separation between the positive and the negative charge. Dipole, it means that 2 pole. Di, it means that 2. Okay, 2 pole, it means that there are 2 poles. And for in kind of electric dipole, so we should have 1 positive and 1 negative charge. In this case, the system consists of 1 positive and 1 negative charge. We call it electric dipole. And for the electric dipole, is produced. What does it mean? The dipole moment. The dipole moment. This one is the physics concept for the dipole. So let's please remember. So 1 positive and 1 negative charge is produce the dipole.
Thầy ơi, thầy vẫn chưa bật chia sẻ màn hình.
Okay, so this one is the physics definition of electric dipole, the separation between positive and negative charge. As you know, that moment is related to the rotation, related to the rotation. However, I won't come detail in the what does it mean the moment here. Okay. And now when we apply this definition of dipole into the molecules. So into the molecular, first of all, we consider each of bond in the molecules. And the first one we have a concept of bond dipole moment. A bond dipole moment. So here we have to encounter the polar covalent bond. Okay, we talk about the polar covalent bond when there is a covalent bond between the two different type of element. For example, here for hydrogen and fluoride, HF here. So because the difference in the electronegativities between the constituting atoms, okay? For example, we have with hydrogen and fluorine, with fluorine. The fluorine is one of the most electronegative element, and hydrogen with much lower electronegativity. So in this case, we can observe a polar covalent bond. And because the fluorine is most electronegative, so they can take or they can attract the electron pair, the sharing electron pair to itself. Or it means that the fluorine here, the surrounding the fluorine atom, this one is electron-rich region. Let's take a look at it here. Okay, so the electron-rich region. And in this case, so when the electron pair is moved towards the fluorine atom, so the hydrogen atoms, this one is the region with the electron poor region. So it means that so the fluoride atoms is has a partial negative charge, and the hydrogen has partial positive charge. And according to the definition of the electric dipole, so there is a separation between the positive and the negative charge. So they produce a dipole moment. Or this one is they produce the electric dipole, and the electric dipole is characterized by a dipole moment. Okay, so this one is a dipole moment. This one is the vector for the dipole moment. The vector is from hydrogen to fluoride. This one is a polar. Okay, so this one is a dipole moment of the HF bond. So this one is when we consider each a bond in the molecules. So when you consider each bond in the molecules, we can determine the bond dipole moment, the bond dipole moment. And so the dipole moment is from the less electronegative atoms to more electronegative atoms. Like, for example, in case of HF here, so it's from the hydrogen atom to the fluorine atoms. This one is a dipole moment vectors. Okay, and now from each bond dipole moment or the dipole moment of each bond, we can determine the overall dipole moment. For example, here is we consider the example for the water molecules, for the water molecule here. So now when you consider each of OH bond here, each OH bond, so because hydrogen is less electronegative than oxygen, so there is so the OH bond, this one, the OH bond is a polar covalent bond, and this bond has a dipole moment, and the vector of the dipole moment is from hydrogen to oxygen, and the same for another OH bond. And now you know that because the water molecules, because the water molecules here is the bent molecular, it's not linear. In case of when the water molecule is linear, you can see that if the water molecule is linear, so these two vectors is cancel each other. So when the two vectors cancel each other, it means that the overall dipole moment of water is 0. However, because here the water molecule is bent, so because when it's bent structure, so when you make a combination of these two vectors, you can find the overall vectors. This one is the overall dipole moment of the water molecules. So in this case, we say that, okay, the water is a polar molecules. Okay, the water here is polar molecules. Now let's consider another example between the CO2, carbon dioxide. So this one is structure of carbon dioxide. Each of CO bond is a polar covalent bond, and the dipole moment here is from carbon to oxygen. However, in this case, you can see that because CO is linear, it depends on the shape of the molecule. Because the CO is linear, so when CO is linear, so these two vectors cancel each other. It means that the overall dipole moment is 0. So in this case, we say that the CO2 is non-polar molecules. Okay, so when you consider these two examples, you understand. So when you consider each molecular, so first of all, we must consider the bond dipole moment. So the dipole moment of each bond, and then you make the combination between the dipole moment of each bond, and we can find the overall dipole moment of the molecules. In case if the dipole moments of the molecule is 0, we say that this one is non-polar molecules, and we use the polar molecules for another reason, for another situation. For example, for water and CO2, you can see that both of them contain 2 bonds, and each bond is polar. However, the overall dipole moment in CO2 is 0 due to the linear shape here, so this one is non-polar. However, for water, yes, when you combine these two vectors, you can find down the overall dipole moment here. In this case, water is polar molecules. What is the problems? Okay. Okay, so first one we understand what are the electric dipole, and then we move to the dipole moment of bond and molecular. Okay, so each bond between the two different elements is possess or has a bond dipole moment, and the overall dipole moment is or the dipole moment of all bonds in the molecules. We can determine the dipole moment of the whole molecules. Okay, this one is a bond and molecular dipole moment. And next one is we consider another type of molecular dipole. So there are 3 types of molecular dipole. The first one is permanent dipole. So the permanent dipole is we consider when the molecular, or we consider this one with the polar molecules, or we can simply say that the polar molecular has permanent dipole. Permanent is always. It's very long time, okay. Vĩnh viễn, okay, the permanent dipole. As a permanent dipole is considered with the polar molecules. The second one is induced dipole. Induced, it means that it's effect from the environment. Effect from environment. For example, here you can consider the first one is non-polar molecules. You can see that this one is a spherical shape with the uniform distribution of the electrons. Okay. However, now let's consider when you add the cations. You put the cations near to the systems. What will happen? Because this one is positive, one is positive charge. So the positive charge is attract the electrons. So when the positive charge attracts the electrons here, so it means that this part is electron-rich region. And another side, this one is electron-poor region. And because this one is electron-rich and electron-poor region, so we can see the separation between the negative and the positive charge. So in this case, you can see that they change from the non-polar to the polars. So in this case, we call this one is dipole, the new dipole. And this dipole is not from the system, because this one is produced by the effect from the environment. In this way, we call it induced dipole. Induced dipole. Okay. It's because of it means that the dipole is formed by the effect from outside, because it's induced. Okay. For example, it's very easy to say like that. You have planned, okay, so this Saturday evening you will stay at home and learn and to prepare for the exam in the next week. Okay, so you are hardworking students. However, your friend asks, okay, so let's go out. For example, go to the cinemas or something like this. And you say it's okay. Okay? In this case, you don't spend time to learn to prepare for the exam in next week. So in this case, we can say that you are a lazy student. However, it's not because you are a lazy student. This one is because your friend. So your friend affects you. Okay, so in this case we call it induce. You are not lazy. You are, in principle, you are a hardworking student. However, because of your friends, you have become lazy. So in this case we call it induce. Okay, induced dipole. So what does it mean, the permanent and the induced? You can see that the permanent is considered for the polar molecules. How the induced dipole, now we consider the non-polar molecules. However, because the effect of another substance or another particles, this non-polar molecules become polarized. In this case, we say that this one is induced dipole. And another one is oscillating dipole. Oscillating dipole, what does it mean, oscillating dipole? Oscillating dipole is not from the outside. This one from the inside. Okay, so what does it mean, oscillating? Because you know that in the chemical system, it consists of electrons and nucleus, and the electron is moving, always move with very fast. It's very fast moving. Okay, and due to the movement of the movement of the electrons, and sometimes the electron densities is not equally like this, and sometimes the electrons, it's okay, sometimes electrons move to this part more than another part. So in this case, this one become the negative and this one is become positive, and it's why you can see here. So now we can see the formation of the dipole, the movement of the dipole here, because of the movement or because of the vibration of the electrons. So this can be called is oscillating dipole, because oscillating dipole. Okay, now this one is molecular dipoles, and maybe it's very hard, a little bit hard for you to understand this point. However, maybe I will make an example in Vietnamese. It's easy for you to understand. Về bản chất thì con người chả ai xấu cả, ai cũng thiện, ai cũng đẹp, đúng không ạ? Như vậy có thể nói là cái thiện, cái đẹp là permanent, là mãi mãi, đúng không ạ? Nhưng ví dụ vì một cái hoàn cảnh nào đó con người đã nó trở nên xấu xa, vì một cái hoàn cảnh từ phía bên ngoài, đúng không? Thì cái xấu đấy, đúng không? Ta tạm thời ta gọi là induced dipole. Nó không vĩnh viễn, nó không tồn tại vĩnh viễn, nó không phải là bản chất, nó là do tác động từ phía môi trường. Thế nhưng mà cái oscillating dipole này thì thưa rằng đó, người có thiện đến đâu thì lúc nào ít nhất thi thoảng có cái suy nghĩ xấu, suy nghĩ tiêu cực, cái đấy đúng không? Thì gọi là oscillating dipole. Đấy, ba cái ví dụ, thế nào gọi là permanent, thế nào là induced và thế nào là oscillating, đúng không? Thì ta hiểu permanent là cái bản chất vốn có, là cái thể hiện vĩnh viễn lâu dài đó. Còn induced là do hoàn cảnh tạo ra, do cái yếu tố bên ngoài môi trường tác động. Và cái này nó sẽ chỉ duy trì khi một yếu tố bên ngoài. Like induced dipole is not permanent. Induced is only exist when there is a effect from environment. When you say, okay, let's stop the effect from environment, so the system become the nature, its natures. Như vậy là nếu một cái phân tử mà nó không có dipole nữa, nếu nó có induced dipole thì chỉ khi mà có tác động từ phía bên ngoài, còn nếu không có tác động từ phía bên ngoài nữa thì nó lại quay trở lại cái trạng thái ban đầu của nó. Thế còn cái oscillating dipole thì nó lại là cái bản chất, cái này là bản chất của cái gì nữa, cái này là bản chất của vật chất đúng không? Cái oscillating dipole lúc nào nó chả có electron nó chuyển động, mà có electron chuyển động thì không phải lúc nào electron nó cũng chuyển động cũng đông nhất. Vậy là cái oscillating dipole ta thấy oscillating dipole nó sẽ là một cái tồn tại, nhưng mà thời gian tồn tại của nó rất ngắn, trong khoảnh khắc thôi đó, trong khoảnh khắc đó, cái này là trong khoảnh khắc. Thế mà tuy rằng trong khoảnh khắc nhưng mà cái oscillating dipole thì vẫn vô cùng quan trọng. Để ta sẽ thêm các ví dụ phía sau. Đấy, như vậy là để ta hiểu nhỉ, để ta hiểu nó là cái gì đúng không? Nói thì nó phức tạp nhưng mà về bản chất thì nó chỉ có vậy. Rồi, okay, let's continue. Now we can consider the last 5 interactions. What does it mean? Ion dipole, ion induced dipole, dipole, induced dipole, oscillating dipole, and induced dipole. If you really understand what does it mean, the molecular dipoles, so you don't need to take a look on another slide. You can understand anything from the name of the interaction here. However, let's make the illustrations for each of interactions. I'm not really sure that you understand what does it mean, the dipole. First one is the ion and dipole interactions. It's very clear here, okay? So the ions have a charge and the dipole is the negative and the positive. And the interaction between ion and dipole interaction is an electrostatic attraction between ions and permanent molecular dipole. Positive and negative, negative and positive is attractions. Okay, the attraction. For example, here you have the sodium chloride in the solutions. In the sodium chloride solid, only the sodium cations and chloride anions. However, when you dissolve sodium chloride in waters, now what happened when you dissolve sodium chloride in waters? Because you can see that because of water, so the sodium chloride can dissolve. And when the sodium chloride dissolve in waters, the water, and now you can see that the sodium and the chlorine and chloride is surrounding by the water molecules. Or you can see that I say that, okay, the sodium chloride is broken down because the waters. Let's consider the water, sodium chloride is a couple, and now this couple is broken down because the third person, this one is waters. Okay, so let's continue. Sorry, maybe. So in this picture, you can see here. Okay, so in the solid state, we know that